The word radar means different things to different people. To some of us, a radar range is where you pop corn. To others, it's the dreaded radar speed gun the officer uses to help us understand why the wheels of our automobile left the ground when we went over the hill just outside of town. But to a pilot arriving at a terminal area for approach and landing, it has an entirely different meaning. Radar serves as the eyes of the controller, letting him help you arrive safely on the runway. When you're flying IFR into an airport with instrument approaches, you'll usually get some form of radar assistance from either approach control or center. That radar assistance can include lining you up on the final approach course, identifying approach fixes for you, monitoring your approach when it's close to another approach course, or, in some cases, radar guidance for the entire approach. By far, the majority of your instrument approaches, unless you request something different for practice, will involve a radar vector to the final approach course at least a couple of miles outside the final approach fix. Why? Primarily to speed up the flow of traffic. When ATC uses radar vectors, they can maintain aircraft separation and obstruction clearance much more efficiently while feeding aircraft to the final approach course. They gain that efficiency by eliminating procedure turns and long initial approach segments. And since a radar controller knows exactly where everyone is, he can legally maintain tighter spacing between aircraft than a controller without radar. When you're being vectored for an approach, the controller usually gives you heading and altitude assignments that set you up to intercept the final approach course. Of course, when I was a student, on my first few approaches, I saw the approach course twice. Once when I dove through it on the initial vector, the next time when I recovered at the runway threshold. Hopefully, you won't have similar problems. The interception will usually be at a 20 to 30 degree angle 2 to 3 miles from the final approach fix at an appropriate altitude for that segment. Then, when separation allows, the controller will clear you for the approach. Now, if the controller has not cleared you for the approach, but intends for you to track the final approach course inbound, he will advise you of this. The clearance will sound something like this: Cessna 9er Echo Sierra, intercept the localizer and track it inbound. Pretty clear, right? Sure, except they usually say it a whole lot faster than that. And sometimes they speak at 60 with peak gusts to 90. And there have been times I thought their lips might actually catch fire at the end of a clearance. The bottom line is, if you don't understand what they said, ask them to repeat it more slowly. But what if you're being vectored and you're about to intercept the final approach course and the controller hasn't cleared you for the approach? If the controller hasn't said those magic words, cleared for the approach, or hasn't instructed you to track the final approach course inbound, then you must remain on your last assigned heading. It could be that, in order to improve spacing, the controller intends for you to fly through the final. He plans to give you vectors to intercept the final approach course from the other side. The controller should tell you if he's intentionally vectoring you through the final approach course, but even if he hasn't done that, don't turn on your own. Call the controller and say, 9er Echo Sierra, crossing approach course, please advise. When the controller clears you for the approach, he will usually say something like, Cessna 9er Echo Sierra, 3 miles from the outer marker, turn right heading 320 degrees, maintain 4,000 feet until established on the localizer, cleared ILS runway 35 approach. Anytime you are cleared for an approach, you maintain your last assigned altitude until you are established on a published route or approach segment. That means you stay at your last assigned altitude until you actually intercept the course. So in this case, you'd maintain 4,000 feet until you are established on the localizer. Radar assistance can be especially useful on an approach if you've had an equipment failure. Say, for example, that you were landing at San Diego's Lindbergh Field, cleared for the localizer runway 27 approach, and one of your nav radios and your GPS failed. You suspect this failure because you see a few puffs of white smoke coming from behind the panel, which could mean that the equipment has indeed failed or that a new pope has been elected. Well, without DME or an IFR GPS, you would need to switch your remaining nav radio from the localizer to POGI VORTAC so you can identify the final approach fix, REBO. But an easier way to identify REBO is to ask the controller to tell you when you're there. When an airport has surveillance radar, which is not something we use to keep our cars from being broken into at the airport, the controller can use it to identify when you're crossing fixes on the approach. He can do this for any fix up through the final approach fix. Now, there are some approaches, like the ILS runway 29 into Oakland, California, that have notes telling you DME or radar required. Since DME is not in the title of the approach, you don't have to have it to fly it. But to identify ALVAR, you must use either DME or radar. So, if you did not have DME or an IFR GPS, you would ask the controller to tell you when you've reached ALVAR intersection. And in that case, if ATC radar were inoperative, you wouldn't be able to shoot this approach. A friend of mine once asked a controller if he would call the fix MATWA for him. And the controller said, sure. Then proceeded to say, here MATWA, here boy. Well, I think you could see that controller had a great sense of humor. There are also approaches where the radar controller does all your navigation work for the approach. These are called radar approaches, and all you have to do is follow the controller's instructions and descend when he tells you to. The only equipment you need to shoot a radar approach is a comm radio, because all you're doing is listening to the controller and following his instructions. Radar approaches have been primarily used by the military, so you'll generally only find them at joint-use civil and military airports. Controllers use two different types of radar for radar approaches. Airport surveillance radar, or ASR, for non-precision approaches, and precision approach radar, or PAR, for radar approaches with vertical guidance. If an airport has an ASR approach, the controller can use the radar not only to line you up with the extended center line, but also to guide you all the way to the runway. How do you know if an airport, for instance, Roswell, New Mexico, has a radar approach? Well, other than the fact that Roswell is where all the UFOs go to shoot their approaches, we can look at the plan view under the communications information for the abbreviations ASR or PAR. If you see ASR or PAR, in this case you see ASR, go to the front section of the NOS approach chart book and look in the radar minimum section for details. As you can see, Roswell has an ASR approach to runways 3, 17, 35, and 21. ASR approaches have the same visibility requirements and heights above touchdown as a typical non-precision approach. For runway 3, the visibility requirement is 1 mile. The height above touchdown requirement is 355 feet. Now, you don't get any vertical guidance on an ASR approach, but the controller will tell you when to start your descent to the MDA or to a step-down fix minimum crossing altitude, your position on final each mile from the runway, when you're at the missed approach point, and, if you request it, recommended altitudes at each mile on the approach, which all sounds great, but here's one even better. As you can see, Fort Huachuca, Sierra Vista, Arizona, has PAR approaches to runways 8 and 26. If an airport has published PAR approach minimums, you get similar visibility minimums and decision heights as you would on an ILS. The required visibility for the PAR runway 8 approach is 3/4 of a mile, and the height above touchdown is 200 feet. The reason you get the low minimums is because with a PAR approach, you get vertical guidance just as you do on an ILS. The difference is that on a PAR approach, the vertical guidance comes from the controller. He not only gives you vectors for the final approach course, he also tells you when to start your descent and then tells you how you're doing in relation to the glide slope. He would even advise you about any trends he sees developing. For example, the controller might say, Cessna 9er Echo Sierra, slightly above glide path, coming down slowly. In that case, you would hold your current descent rate until the controller says Cessna 9er Echo Sierra on glide path. Then you would slow your descent rate to what you think would hold you on glide path. You will find radar assistance on the approach particularly handy if you're in the clouds and lose your vacuum system, which, by the way, has nothing to do with how you keep the airplane clean. But if your gyro goes kaput, the controller can give you no gyro vectors for either a radar approach, if available, or for a published approach procedure such as an ILS or VOR. When you're receiving no gyro vectors, the controller puts you on the required heading by telling you when to start and stop your turn. He'll say, for example, Cessna 9er Echo Sierra, turn left. When you hear that, promptly start a standard rate left turn and hold it until you hear Cessna 9er Echo Sierra, stop turn. The controller uses time to control the amount of turn he wants you to make. So it's important to start and stop the turns on his calls and to make them standard rate. Now, once you're on final, you'll use half standard rate turns because that's what the controller expects and it's what his instructions are based on. Then you'll just follow the controller's instructions all the way to the airport for landing. So, while you may not like those radar guns out on the highway, radar in the terminal area is pretty useful. It's one more handy tool to help you arrive safely at the airport.